Okay, everyone, let's start. Thank you for joining us for this presentation of how you can unlock new opportunities through adoption of software-defined storage. And I'll also cover a bonus discussion on what software-defined storage vendors are not telling you. So I'll go through the slides, and if you have any questions, put them in the chat, and I'll come back to them at the end of the presentation. I'll do my best to give a very high-level overview without going too much into technical jargon. So I keep it kind of simple for you. And if you have any more questions, or if you want to dig down in technology, feel free to reach out. What we're going to cover today is how technology can help you drive business value. So that's kind of the essence of technology. We're going to show you how good technology can directly increase the efficiency of your business, in kind of measurable terms like average user revenue, or reducing infrastructure costs, etc. And some of the benefits of good technology are more intangible, like decreasing customer churn, word of mouth growth, happier customers, less support tickets. These are all the two sides of the same coin. And of course, we're going to explain what sometimes you have to read between the lines when you chat with other storage vendors. A bit about myself. I'm one of the co-founders of StorePool, and we basically help companies that are building public or private clouds to do better clouds. Prior to StorePool, I have co-founded a number of companies, and I also worked as an employee in small and large enterprises. In my days at StorePool, days and nights, we've been talking to literally hundreds of companies that are building public or private clouds at all kinds of scale, from 5-10 terabytes to petabytes of storage systems. And we have a lot of workloads that are running on StorePool. Like we have customers like SiteGround and Cloud Sigma, and we have a lot of our customers are hosting workloads for some of the biggest companies in the world, like CERN and Siemens and Deutsche Börse, etc. So we've seen a thing or two about clouds, and we help build a bunch of these. So I want to start with a 10,000 feet, 30,000 feet overview about what you see in the market in terms of companies and how they adopt innovation, how they think about technology, how they think about innovation. So we have 4 groups of companies, and we basically label them as the disruptor, the innovator, the Me Too, and the laggard. And I'll quickly go through all these. So disruptor is a company that usually takes the industry by storm. It's very hard to replicate this success, and it's not a strategy. These are companies like AWS, Google, DigitalOcean, and other businesses that just create a product that hits the nerve of the market or has something so unique and differentiative that they are able to capture a large market or create entirely new market. And that's good for them, but it's very hard to replicate as a strategy. I think we're biggest fans of the company we call the innovator, which is a company that just has innovation at the core of its values. So it's kind of like a systematic innovator. So they constantly look of how they can improve their service for the customers, create new services, and build what the market needs. And this is how you kind of repeatedly stay ahead of the rest of the companies on the market. So this is, it's like running or any other activity that you do. It's not a one-off activity. It's just like a process. We have the Me Too companies, and when we describe it, some of the people that are managing or working these companies, they sometimes recognize themselves, and sometimes they have this motto: I use tier 1 vendors, therefore I'm a tier 1 provider, which sometimes is a valid strategy, for specific market segments or specific points in time. But most of the time, these are just companies that are driven by inertia. They're doing what everybody else is doing, so basically they're behind the curve. And we have the companies that are falling behind, and they basically don't want to innovate. They don't know how to innovate. They don't have the vision. They don't have the mindset. They don't have the strategy. And these companies, in many cases, they don't have a business. They either have to re-engineer their company, their technology, or they have to kind of do something with the remains of the business. And we see them, and you can spot them with very, usually technical things. You see, you open their website, it feels like stuck in the 90s, 98, 99, still using slow networks, high latency, they don't have a proper cloud infrastructure. You can sense by the small things usually. And if you haven't seen this graph, which is the diffusion of innovation, you can Google it up. It's a very interesting curve of how new technology gets adopted by the market. And there are several categories of who are the people that adopt a different technology or new technology, and what is your driver. So basically map this to our simplified way of looking at the market for practical reasons, which we have the disruptor, the innovator, the me too, and the laggard. So obviously they fall in different parts of the curve of what type of technology they adopt. Is it mainstream? Is it innovative? And we figured out that if you want to innovate your business, if you want to unlock new potential, usually there is something that prevents your business from doing so. And we kind of figured out that there are three major categories of underlying technology, not always technology, but three broad categories of things that prevent you from growing a business. And the first thing is reliability issues or downtime. And that basically translates directly to business metrics like customer churn, no word of mouth growth, more support tickets and things like that. So a customer of ours from the UK and US, they operate in a couple of markets. They called it the sleepability factor. They said prior to kind of fixing our infrastructure, we had such severe reliability issues that we were not comfortable in selling our service or marketing our service. But more importantly, we were afraid to go to sleep because had a number of issues or accidents where we got woken up at 2 a.m. So that's kind of like if you're not sure in kind of the capabilities of your technology, then your business is flawed from their own. The other thing is the market obviously evolves, and what used to be kind of a new feature or new technology that can differentiate your company from a different company is no longer enough, because the innovation is speeding up. So in many cases, it's all about performance, flexibility, new technologies or new capabilities of the product or service that you're offering. And the third broad category, which we see almost nobody talking about, which is a major trend, is the lack of good qualified people in IT, or they're very scarce, very expensive to hire. And I think my personal opinion, after talking to many business executives, is that this is to a large extent the driver of people going to cloud services, to public cloud services. They have hard time hiring people, retaining people, training people, and they're paying huge commissions to headhunters and recruiting agencies. And I think sourcing talent for growing your business in the IT domain is a very big driver of adopting new technology. So here we kind of list a bunch of the technical things that can make or break a business, because in the end, the technology is the underlying fundamental of the business. So you have performance and latency and cost and scalability, flexibility, etc. And God forbid, loss of data. which unfortunately is a fact of life. So technology should be doing everything possible to prevent any such situations, and obviously a big part of it is training your team and having the right people in the right places. So we're getting to how to get business value by using these new technologies, and a lot of it is basically the process, not the how, but the why, and not tactics, but the big strategy, the process. So it's not what exactly you should do, it's kind of what is the process that you should follow so you can innovate year after year and keep your business growing and being recommended by customers, attracting new customers. And a lot of it is things that are related to IT infrastructure if you're running a cloud, obviously, and a lot of it is storage related. So one is the faster service, which basically reduces churn. I think performance and reliability are the two main factors that we've seen to turn off customers. They say this service is not reliable, or this service is too slow, or performance is unpredictable, and that's kind of like how you lose customers on the bottom end of the funnel. Then downtime, obviously, that's kind of a big issue. We call reliability feature number 0 when somebody comes to you and asks you, about price and about performance and all these things. But if your platform is not rock solid, then all the other bits don't make a lot of difference in the overall value proposition that you have. Obviously, more features would attract more customers, new customers. And something that technology should help businesses do is to provide competitive price performance. So it's capability, but also capability that's cost-efficient capability, and positioning your business in a market segment where you want to be. So these are the customers that matter to you. So we've seen, especially in the hosting industry, we've seen a lot of companies build around the cheapest, lowest priced, most competitive market segment. And they don't have the resources to improve their service. They attract customers with constant discounts, but then these customers are expecting discount after discount. They are not financially viable, or they don't have the mindset to invest in their service. So basically, you end up with customers that might be suboptimal for building a business. So price is an important decision-making factor, but its price performance is even more important, because you want in the end to have something that's well priced but delivers value to people who can appreciate this value. And obviously, all these things tie back to the point of the difficulty of getting and retaining top IT talent. So I have to do it with less people. And people in the current environment are the most expensive resource you can get. So it's not the hardware, it's not the software. Obviously, hardware and software, the physical assets cost money. But then the biggest cost you have as a company, especially in the IT domain, is usually related to staff, and then it's sales and marketing, and then the IT spending is the third one. Although it can improve the economics on all the other stacks, and I'll get back to that in a second. So this is how software-defined storage can help your business. And here we have a comparison of the old days, kind of the traditional stack of building a cloud, which was, you're buying expensive branded servers, running VMware and Xen, and you're buying a dedicated storage box or all-flash array because you needed shared storage for high availability, live migration, basically providing true cloud capabilities. But the problem with this technology, it's great. So this technology is great, but the problem with it is that today it comes at a very low return on investment. So if you use it, it's a good technology, proven technology, but it's not innovative anymore, and the margins you can get by deploying this technology are very low. So we made kind of this ROI calculator that's taking prices of average market prices of cloud services and compares that to building a cloud with the traditional technologies versus building a cloud with a software-defined technologies, which are on the right, which is white box servers, cloud management systems like OpenStack and CloudStack and OpenNebula, and they're using software-defined storage, so you don't have to spend a big chunk of money on storage, but still get all the performance you need, all the reliability, high availability. So a point that we want to kind of make clear is that a storage technology is fundamental for building a cloud. So it can help you with performance of the entire service, the scalability of the entire service. It can reduce costs across the whole stack. It will help you eliminate downtime, and obviously it will help you to save time for your team. So here we want to show a couple of examples that get the message through that are more technical, but this is the underlying reason why storage is fundamental. Regardless of what you're doing on the compute side, what type of VMs you run, what type of applications you run, they usually hit, they have a database or they hit the storage system. And then if you have a storage system that's slow, that basically causes support tickets in your support team. People complaining about their application being slow, their database, their site loading for too long. And in many cases, it's a more complex problem. So in many cases, it's across the stack. Maybe the application was not written efficiently. Maybe the networking connectivity is not wide enough. But in many of the cases, if you have a fast storage system, you can basically solve these issues. Or in many other cases, the storage system is actually the bottleneck. So here we showcase an actual graph from a customer that called us and said, one of our customers, this customer is actually a cloud provider from Switzerland in Europe. So they were calling us and said, okay, we have a customer that's complaining that their particular workloads is slow. So we looked at the storage system that they had, and they had a latency that was about a millisecond. So we did some tuning and we kind of converted these workloads that were running on a different stack to a software-defined storage system. And then the result was about 10 times improvement in latency. And the end result of that is customers saying, thank you. My issues is solved. I don't have any performance issues anymore. So sometimes it's very subtle. The relation between happy customers, more revenue, and growth of the business boils down to small technical things like that. Another thing that we want to make to get as a message, which I think almost no one in the storage industry or cloud industry is speaking about, is the importance of latency. So here we have a graph of what is the latency versus the IOPS per second you can get. And a lot of storage vendors, a lot of cloud operators advertise their IOPS metrics as a measurement of the performance of their system. However, there is this dependency between latency and IOPS. And you're looking ideally to get a system that's very fast in terms of latency. So basically sitting in this system of where does the latency of the storage subsystem start with, because it basically determines the latency of the entire IT stack. So we're looking for a system that's extremely capable and starting, as closer to zero as possible, which would give you the best performance. And as you load this system across this curve, at some point you get a cloud environment that is used by a lot of people or a lot of applications, and obviously it delivers more IOPS and latency goes up because the system gets loaded. And at some point, this system will just become flat. So you can get more IOPS, but the latency will just increase because this straight line on the top is kind of the actual performance capability of the storage system. So if you cannot deliver any more IOPS at this level of latency, you're basically increasing the latency without getting anything out of it. It's just you're getting more IOPS, but the latency of this IOPS is becoming so big that the end user experience is getting worse. And for the people that are not in the storage industry, it might come as a surprise that pretty much any vendor that publishes benchmarks of how powerful their system is actually doing this thing. They're showing you the maximum level of IOPS that the system can get when it's highly queued, like many applications are fighting for the same IO, which means extreme levels of latency. But if you look at the workloads of your business and your customers' businesses, they're all latency or almost all are latency sensitive. These are databases, these are virtual machines, these are websites, everything that's in many cases running parallel I/O, like a database. Read, write. It doesn't shoot many operations in parallel for the most part. So basically, latency is the most critical feature of a storage system. And here, basically, a good distributed storage or software-defined storage solution can solve all these technical things to improve your business on a business level. The first thing is eliminates downtime, and you'll be surprised of how many companies still fight with hardware issues. It's not storage issues. It's faulty network, compute nodes that are dying, RAM that's burning out, or something that's happening. And you basically need a storage system, that shared storage system, that can survive hardware failure and also can self-heal. So in this system, everything becomes online operation. Upgrading storage, adding new servers, life cycle management of upgrading all your hardware, everything becomes an online operation. So basically get rid of downtime. The other thing you do with a very capable system is to have a system that is so fast that it's 2 to 10 times faster than what you have available on the market today. And basically this is the thing that makes your offering very distinct on the market. Especially that combination between 1 and 2. So it's performance, but also reliability. If you look at today's market, you can get companies that have good reliability like AWS and Google Compute Engine, etc., which are not famous of extremely good performance, or the performance you can get from there is becoming increasingly expensive as you demand more performance and guaranteed IOPS. Or you have services which are extremely fast on local NVMEs, but they don't have any redundancy and high availability. So ideally, you want your cloud to have both 1 and 2. Obviously, we're looking for something that's cost efficient. So a solution that you can build at a smaller scale and it will give you high availability, will give you performance, but will come at lower cost than AWS. And will also allow your company the flexibility to follow the business and the circumstances around this business, like what type of data center do you have, what type of hardware do you have, how much electricity you can get in a data center, all these things that usually software can help you with because it's very malleable, it's very fluid and easy to do many different things, whereas the other things like more rigid hardware configurations and storage arrays cannot deliver. And the other thing you would look for a best of breed storage software to help you with is basically save you time. Those saying goes that you can make more money, but you cannot make any more time. And you want to have somebody that's doing storage for you, which is usually the most problematic piece in a data center. The statistics goes that 50% plus of the support cases in the end are storage related. So you want your IT team to be improving the business, getting more business, creating new services, onboarding customers, migrating customers to your business, rather than spending their days and nights with firefighting issues in the data center. So these are the things that make a good storage system come alive and help you with your business. And I'd like to briefly for another 10 or so minutes, walk you through what are the things that you should be looking at when getting a software-defined storage system and what nobody is telling you on the market. And then we'll open it for Q&A so we can have kind of like an efficient, time-efficient webinar. So the first thing that we wanted to make sure is that people understand that software-defined storage is a technology, and technology is made to serve companies and people, but it cannot solve any all issues. It's good to solving particular issues. So many people think that if you deploy software-defined storage or software-defined networking, and it will solve all their issues, which in many cases is not true. Software-defined storage has a particular set of issues it can solve, and it excels there. And these are usually performance and reliability issues. Although you might have to look at how do you do, for example, highly available applications on a higher level in the software stack. A lot of people come to chat with us about software-defined storage and thinking that they'll get hardware that's running for 5-8 years now in their data center, and they want to decommission it. And because they want to decommission it, they want to use it for something else. And I think the software-defined storage promises that it will run on any hardware, but to a big extent, that's halfway through. So I think it's only a software-defined storage system is going to be as good as your hardware because it uses this underlying hardware. So you can trade off money versus time or vice versa. So if you want to get a very good system, you should spend some time, and this will give you a faster, better system, more reliable system, which will be future-proof. If you want to save on money, then you spend time and effort and get suboptimal resources. Basically, the trade-off is you don't spend money for good new hardware that's against standard, but well designed. And if you don't spend money on this hardware, then obviously your performance will be a bottleneck somewhere because you're using old hardware. A lot of vendors at some point when software-defined storage became such a buzzword, you open up a website of a storage vendor and they'll claim all the same things, savings of 70-80%. And that depends a great deal on the state that you have today in your business. There are some companies that are running local storage which doesn't have the capabilities of true cloud infrastructure, so high availability, live migration, hardware tolerance, hardware failure tolerance, self-healing. So basically it's cheaper, but it's not the same thing. So if you're looking at companies that are building extremely expensive cloud with tier 1 vendors, then in this case, you can have even higher savings than the 80% that are mentioned here. So I think there are a couple of points here. One is the cost savings you would get with software-defined storage depend on your particular situation. And then these cost savings vary a lot vendor by vendor, because this is the true differentiator of storage software vendors, is how good their product works and can it deliver cost efficiency across the stack, meaning servers, compute, networking, when you add up all the bits and pieces, because everybody promises you that they'll deliver the moon, but very few people can actually deliver what they promise. So I think this is a big point here. Another thing is that the elusive concept of doing all-in-one unified storage solutions, which is usually block, object, and file, which is a very good concept, except it's kind of like a sports car that's also a truck. And in real life, it doesn't work too well. So the software code that you need to do a fast system that can do that can run databases is very different from a storage system that is needed for storing billions of images, for example. So in the end, if you want to have a good solution for any of these use cases, you're better off with getting a proper solution for this use case and a different best-of-breed solution for the other use case, rather than a one solution that will do everything. We've seen a lot of vendors and a lot of people that are trying to cut costs, and then in the end they shoot themselves in the foot. And a big part of it is people that are trying to save money on the wrong places, at the wrong points in the technology stack. And one thing is, like, people say, I want to use software-defined storage, but I'm going to use with 3 times replication. Well, guess what? That will guarantee to lose you data at some point. And it's very simple why you have just, system that's spread over, let's say, 10 physical servers, but it spreads the data. You have one server that fails. If you have 2 times replication, one of the copies is out. And if you have just one drive that fails in that moment, that will lose data. I think, like, the research that Google was the pioneer of doing, kind of systems that are distributed systems of very large scale. They have this golden rule of 3 copies is the ultimate trade-off between extra reliability of the systems and resilience and extra cost. So they said, like, 2 copies is not enough for long data longevity. 4 copies is too cache intensive. So 3 copies seems to be the best trade-off. So I think triple replication is a must for primary storage systems. A lot of the small things you can compare software-defined storage solutions by is their data integrity functionality. And this is something that nobody's telling you, and people don't know about this. So basically, if you have a system that starts to scale to 100 terabytes, 1 petabyte, 2 petabytes above, you need to have a very intelligent algorithm built in the software system that knows which piece of data was overwritten, what is the status of the data, etc. So I think I haven't seen systems that software-defined storage system that have good enough level of data integrity. So I think there are just a couple of systems that they deliver good enough or the best of breed data integrity functionality. And we have a lot of issues that are happening in the software stack, but a lot of issues that are happening in hardware, like SSDs, NVMe's, network. So basically, this is a must-have feature. And if you have to remember one thing of the presentation, or 2 things, one is ask your vendor for latency, look for low latency system, and the other thing is, like, look for software-defined storage system that can have a data integrity functionality that will guarantee as much as possible that your data, whatever you put in the system, is the data that you get back. Another big thing that we hear often is about deduplication and compression, that these are the must-have features. And I want to say that this is true for a very limited amount of cases when you're building a public cloud offering. If you're building a private cloud offering, sometimes these features also make sense. But I think these features were heavily advertised by the marketing departments of all flash vendors, just because their storage devices were so expensive in the first place. So they had to figure out a marketing way to kind of claim that they can store 5 times more data than they can store. So, the economics or the price that you'll get is not ridiculously high. And obviously, these features work for some use cases and some types of data, but for the businesses that are doing public clouds, hosting services, virtual machines for internal IT and private clouds for the most bit, this technology usually would not do a lot of gains. And there are other technologies that would be doing better job at reducing the cost of your system. It's actually a cost optimization. And yeah, my last point is, again, the latency, which should be the #1 storage metric you're looking at. And anything that's above 1 millisecond of latency for production workload for primary storage system, in our view, is too high for a latency of a storage system. And I have an example of chatting to kind of one of the storage engineers at the bank who said, like, we have this big database that has 3 milliseconds latency. So, well, that seems to be the latency of the storage system, not the latency of the database. So if I have a storage system that can do 100 microseconds of latency, that's going to be 30 times faster database for the customers of the bank. So it's kind of, this is the thing that you have to look for. And I think with this, my slides are done, and we're opening up for questions. I'll switch to the other screen to see if there are any questions. No, don't see questions so far. You can use the small pop-up on the top of the screen on the left side. And if you want to have more technical presentations or something that you want to know about implementing software-defined storage technology, just send us an email at info@storpo.com, and we'll be happy to help you out. And we will basically do our best to be very informative, and we're not this type of company that would try to sell you something unless we think we can really help you achieve your goals, in which case we'll make our best to design something custom for you, and we'll be very upfront if we think that you're better off with somebody else. So feel free to reach out to us, and we'll be happy to share our expertise. Thanks.